Now what I'd like to do is turn our attention to some descriptive statistics. So let's run descriptives on the measurements that we had before, the height and shoe size data. So first, let's calculate the mean of height, and we'll do that the long way. We're going to call this heightbar. So doing it the long way means just calculating it using the formula. So the sum of the height divided by the length of height, or the number of height observations we have. So heightbar equals sum height divided by length height. And if you go in, type heightbar, you'll see that it's 70. We also have that in RStudio to the right in our workspace. Heightbar equal to 70. So what I'd like to do now is do the same thing, just instead of doing it out by hand or the long way, let's do it with the R command instead. So now we'll write heightbar is equal to the mean of height, and that's the command for mean here, mean height. Heightbar again, you'll see equal to 70. I'm going to do the same thing for shoe size now. So shoebar is going to be equal to mean shoe. Put that in, hit enter, type shoebar, and we'll check it out. Here we do have shoebar on the right, shoebar on our console, both equal to 10. Now I'd like to calculate variance and standard deviation. So we're going to do the same thing. We're going to do it first the long way using the formula. And then the second way we'll do is by calling it through the R commands. So in order to do this, we're going to want to create a vector of error scores. So we're going to create a shoeerr variable. That's going to be equal to shoe minus shoebar. So we're just taking the raw score minus the mean, and then since it's a vector, it'll do that for each observation. Now we're going to want to create a vector of squared error scores, and we'll have shoeerr squared equal to shoeerr raised to the second power, and again, as a vector, it'll do that for each observation in our vector. The next thing we want to do is create a variable for the sum of squares, the sum of the squared error for shoes. So SS is the variable that we'll call it. That'll be equal to the sum of shoeerr square. And you can look on the right over there in workspace, and you'll see SS is equal to 52. Next thing we'd like to do is create a variable for n. N is simply going to be the length of the shoe. That's going to be the number of observations we have for shoe. And then finally, you're going to want to create a variable for the degrees of freedom. We'll call that df. And that'll simply be equal to n minus 1. And on the right, you'll see that we had df is over there equal to 7. And it says 8L at the top there, so it's the length of 8. Now we're going to create a variable for the variance. V is equal to the sums of squares SS divided by the degrees of freedom df. And you'll look to the right and you'll see V 7.42 or so. We'll create a variable for the standard deviation next. Call that S is equal to the square root SQRT of V, the square root of the variance. And over to the right you'll see that's equal to 2.72 and so on. Now let's do the same thing using the commands. V equal to var shoe. Var shoe gives you just the variance of the variable shoe. And hit enter and type in V, and you'll see again it's equal to 7.42 and more. S is equal to the SD of shoe. That's the standard deviation of shoe. And S, if you hit enter, after you type S, you'll get the standard deviation, which is 2.72, etc., which is exactly the same that we had before. Now let's do the same for z-score, and we'll use the calculations that we had before. So z of shoe will be equal to the error score for shoe, shoeerr, divided by S, the standard deviation, and that'll give us a z-score for each of our shoe sizes. And there we have them. Once you type in z shoe, you can hit enter, and you'll see all the z-scores. So now let's create the z-score by command in R, and that function is scale. So we're going to type z equals scale shoe, and once again type in z. You'll find that we have the same numbers. Down below you'll say attribute is scaled at the center of 10. That is the shoe bar 10. And attribute scaled scale is the standard deviation 2.72, etc. So it's just giving you a little bit of extra information down there in addition to your z-scores. Now what I'd like to do is finally add all of the variables to our data frame that we had from before. So we'll have height, shoe, we'll also have shoeerrsq, so measurements, $shoeerr, that's, I want to add it into our measurements data set. I want a new variable called shoeerr, and I want it to be equal to the shoeerr vector. I'm going to do the same thing for shoeerr², so we'll have a shoe squared error variable defined as what we found for the vector of shoeerr², and I'll do the same thing for the z-score. Enter in a new z-shoe variable into our measurements data frame and define that as equal to the z vector. Finally, let's check out our new data frame. So all we have to do is type in measurements, and it should have all of those variables in it. Height, shoe, sex, shoeerr, shoe squared error, and the z-score for the shoe. Thank you all for listening, and I hope to see you again for our next podcast.